So I'd now like to end this portion of the class by talking a little bit about what I mean when I said descriptive statistics. And descriptive statistics are any statistics that describe the data that you have in front of you in a sample or population. So if you're looking at sentences or if you're looking at number of arrests, descriptive statistics let you take a look at that data and just understand what's going on in that particular sample or population if it's a population. Descriptive statistics include frequency tables, measures of central tendency, so the mean, the median, or the mode, and measures of variability, and especially the standard deviation as we just talked about today. So congratulations, you know how to find descriptive statistics, and now you also know what they're called. So when this class is broken up into units, this is the end of the first unit, and so what this really gives you the tools to do is look at data and understand what's going on in a particular data set. With that, I'm going to finish out this lecture by talking a little bit about statistical programs. So if you imagine for a moment that you're looking at a data set with 1,000 cases or even 10,000 cases, just about everything we've done in this class would be completely impossible. We're not going to be listing out 1,000 or 10,000 observations. We're not going to be going through all the calculations that we just did with 1,000 or 10,000 observations. Instead, most of the time, if you're working with data and looking for descriptive statistics, or any kind of statistics, you're going to be using some sort of software to do that. And in this class, I'm not going to ask you to use any software because we're online, there's a virtual lab, but I have no idea how well that works on different kinds of computers, and I'm just not going to go there. But it's still useful to be familiar with them and to get a sense for how statistics is actually done in the real world. To do that, I'm going to talk a little bit about variable coding. And this is something that if you're ever in a job where you need to work with a data set, you'll need to know this. So when we use software to look at statistics, we typically code variables. This means that we assign numbers to different variable attributes just for the purposes of storing them and analyzing them within the program. And you can do this for variables at any level of measurement. So as an example, with a nominal level variable, you could code females as 1 and males as 0. And typically when you have something with two categories, it's standard to code them as a 1 and a 0. You could have an ordinal variable. So if we're talking about level of happiness, you could code each of these different ordinal attributes as a 1, a 2, a 3, or a 4. An example of an interval level variable, so something like exam grade. These are already numbers, so that's pretty easy to convert into a numerical code. And then with ratio variables, you already have numbers, so you'd be pretty good making a numerical code. So number of dogs owned, 0 is going to be 0 dogs, 1 is going to be 1 dog, and so on. What this looks like is something like this. And this is an example of a bunch of different variables that have been coded in the way that I just showed on the slide. And they're listed out for each case. So you'd interpret this by saying that for case 1, our top row on this table, we have I forget how I coded on the last slide, but I think we have a gender of male. We have a very high level of happiness, so we have a 4 on our happiness scale from 1 to 4. We have an exam grade of 90, and we own 0 dogs. For case number 3 there, we have a gender of female. We are, somewhat happy, I believe, on the happiness scale. I should really remember what I just said on the last slide, but I absolutely don't. So we have a 3 on the happiness scale. We got a 30 on our test, but we own 7 dogs, so we're in business. And so that's what data looks like when it's coded. And as a side note here, once data is coded, you can often treat these nominal and ordinal level variables as numerical. And so, for example, you could find the mean level of happiness for people in this data set, and it would be a mean based on these numbers that are in the column labeled as happiness. The only thing is that you have to keep in mind what they mean. So if you find a mean of 3.2 for happiness, you're going to have to understand that, that's a mean that's a little bit above your somewhat happy label that is an ordinal label. And also keep in mind that for some variables, it would be completely meaningless to find something like a mean. So you might remember that at the beginning of the class, I showed you data from our class survey. And it was in a format like this. So this is data from the class survey again. And what you can see here now is that all of these different variables are coded. And so I assigned numerical values to each of the different survey responses and coded them in here like this. So if you look at the column for siblings, for example, those are just the different numbers of siblings that different people reported in the class. If you look at the column for police satisfaction, that's coded so that a 4 is the highest level of police satisfaction, a 1 is the lowest level of police satisfaction, and then you have the two middle levels in between. Still, just looking at a big spreadsheet like this isn't too helpful. Why we put it in this form, though, is that this can be read by a statistical program on a computer, and then it can pop out just about anything you need. So here I'm going to give examples for one statistical program called SPSS. This one, I believe, is still the most commonly used one for government programs. It pops up a lot, so there's a good chance that if you get a job where you need to do statistics, you'll need to learn SPSS. But there are other statistical programs out there, and everybody, has their favorite, and it's a whole thing. So this is, again, a quick guide to SPSS. I'm not going to be expecting you to use SPSS in this class, again, because we're remote, but I do expect you to have a sense for how you go from a page that looks like this to statistics just using a program like this. And then we'll talk about how to interpret the output. All right, so if you open a data set in SPSS, you get a screen that looks like this, which is just the coded data. And this is class data from a few years ago. So if you squint, you can see there's some slightly different questions on there. And there you can look at the variables and get some different information about them. Again, since you're not working with it, I'm not going to spend a whole lot of time going through each of these things. But here's how easy it is to get descriptive statistics if you're working with a computer program. You can go into a tab, go to Analyze Descriptive Statistics, click a thing that says Frequencies, put in some variables, and again, you don't need to know the specifics of all of this. This is just showing what it looks like and how quick it actually is. Click on Statistics, continue, hit some more OK buttons, and then get descriptive statistics. So all that math that I make you do in here, nobody ever does when they're actually doing this in the real world. Helpful to know what the numbers mean, but typically to get descriptive statistics, you're just going to do something like this, do a few clicks, and then as you can see here, we have output from the statistical program, which shows you the mean, median, and mode for this variable, the standard deviation, the variance, and the range, and then has also popped out a frequency distribution along with it. And I believe this variable was how many times a month do you get really drunk. So that's it for your very short guide to statistical computer programs. Again, the only takeaways here are that typically variables are coded, put into a program, and then it'll take you a few clicks or lines of code, depending on how you're doing it, to get your statistics.